Okay, this would be for Math 1101 for Tuesday, September 8, right after Labor Day. This is a lesson that covers the end of section 4.2 on borrowing, specifically mortgages, and the very beginning of 4.3, saving for a nest egg or just saving in general. We're not going to get too far into that, but we do have a few examples, and I'd like to show you kind of what we're up against as far as the by hand calculations, especially regarding mortgages. But first of all, let's get started with a amortization table schedule, and it shows for each payment that made towards your car or whatever you're buying, the amount applied to the interest, and then the amount applied to the balance, which is what you want to pay down, especially, and then the outstanding balance, what you still have left to pay, just in case you're thinking of doing a payoff. If you borrow money to pay for an item, your equity, the item at the given time, is the part that you have paid. That's what you actually have put down as far as the balance is concerned, what you kind of own, basically, of the car. And it may be a smaller percentage than you think, especially in the beginning. But let's take a look by way of an example, as we always do, and using the formulas and showing whatever computations we need. Suppose you need to borrow $1,000 at 12% APR. That's a very convenient one for 12 monthly payments. And that's what it'll be, 12 monthly payments. And 12 divided by 12 is 1. That's going to be 1% for your R. And make a table, though, showing the payments over the first 5 months. And what would your equity in the computer be after 5 payments? So you're buying a computer, and what would your equity be? What would you own? Okay, let's go to the next slide. And of course, as we mentioned earlier, the monthly rate, which is called R, also known as APR over N. And make sure I can turn my pen on and make sure I can print it on the screen. And let's see. Nope, it's not printing on the screen. Not sure why, but I'll get that going in just a minute. APR over N is equal to your R, and that's one of the easiest of all. 1% per month, 12% per year, 0.01 for your calculator. So with T equals 12 months, we have a amount borrowed would be a monthly payment, which is going to be multiplied by 1 plus R to the T minus 1, and we've seen this formula before. I'll just let you look at that. Of course, we are going to put in $1,000. That's what was borrowed, and so this is actually a mistake here. We've got the wrong formula, so this is a tragic error. So let me X that out and just go ahead and put down the inverse of this, and I'm going to abbreviate it because I don't have a lot of room on the screen here. Monthly payment is what we're looking for, not the amount borrowed. We already know the amount borrowed. Amount borrowed, AB, that's the 1,000 right there. And then we just kind of flip these two around because they're almost the same formula. And I've seen people actually kind of redo the formulas just because they didn't have it directly, but that's okay. Don't really have to do that, but it does work. So I'm going to put down I'll put dots instead of X's, and then 1 plus R to the T, and then we'll, of course, subtract 1. And let me slip in the real numbers that really work. The amount borrowed, of course, 1,000. What we're looking for is the monthly payment, not the amount borrowed. So this is the wrong formula on this particular slide. They have made a couple of mistakes on this particular lesson. Okay, so then we have R. R is 0.01. I'll use parentheses. 1 plus R is 1.01. That's just simply raised to the 12th. We'll take that exact same number and subtract 1 from that. And you don't need parentheses on that if you don't care to do that. So let me put in a few extra steps for you. Because it's not a mortgage, I would recommend 5 or probably 6 decimal places. You can go for more if you'd like, but it probably won't make any difference. If I see a good faith attempt and it's off by a couple pennies, I certainly do not worry about that. So I like to get these first two numbers together. They don't really mean anything, but it's very simple to multiply those out. Get a 10. Now 1.01 to the 12th, let's just find out what that would be on a calculator, and you can check this, of course. You'll get 1.126825. And that's to 6 decimals. That seems to be enough. And if we take that same exact number, notice how these are the same. Just subtract 1, and you get 0.126825. A lot of repetition. I'll put the 0 in for emphasis. And then, when you divide that out, then you actually do truly get the 8885. but they had a misprint. And I apologize for that. That's why I'm here to correct it. I am writing at an angle, so the handwriting isn't the best. Well, anyway, now we've got our 8885. That seems to be a recurring theme. And to build these tables, and they're not super thrilling to do, but it does show you a point that they're making. The interest on the first payment, the first period of time, first month, is $10. 1% per month of the 1,000. That means you're paying on in the first month $10. Because the payment has to be $88.85, and we take the $10 away for the interest. Well, actually, that's what you're actually paying to the principal. And so we've got $78.85 to the interest, and the outstanding balance is the subtraction of all of that. So we're paying $78.85 and then $10. That's for the interest. And so that's looks like another possible mistake. But let me go ahead and skip ahead so we know what we're looking for. We apply the $10 to interest, as we see here. And the pen keeps turning off, and we have $78.85 after that. Let me just see if I can get my other pen to work. Maybe it's a little bit sharper. Let's see if I can get that to go. Okay, so we have the $78.85 applied to the balance owed, so that's the difference. See, so this is to the balance. Another mistake. Brother, these pens not work. Squeeze, and I just charged them up too. Well, anyway, I can't seem to get things to work very well. Okay, that's to the balance, and so then the outstanding balance, which is a separate question, you subtract it from the 1,000 that you started with, and then it's gone down to $921.15. The good news is, it's such a small period of time, you're not paying as much interest as you are bringing the balance down. The balance is almost $80 per month, and you're only paying $10 in interest. This is quite different than a mortgage, which is like many, many years. So this is actually kind of in your favor to not have to spend so much money in such a long period of time as a short period of time. Well, anyway, the point is, if you were to do these tables by hand, which isn't super entertaining, but we may ask you to do a couple, 3 years or months worth of these, make our second payment. Now the outstanding balance, notice how it's $921.15. And the interest will be only $9.21. Okay, so the interest is already going down, and then we take it away from the standard payment, which has been pre-calculated by the formula. That's everything all put inside. We take away the interest, and this is the balance. Another mistake. A balance, and then the outstanding balance is the difference of the $921.15 minus what we are able to pay the balance down with, nearly $80. In fact, it gets over $80 pretty fast. And then the outstanding balance is $841.51. Let's perhaps see on the next slide. You can always pause this, rewind it if you need to, but let's go to the next slide and see what we just did. We first applied $78.85 to the balance owed, then we went up to $79.64 to the balance owed. So it's getting better, and you see as you continue this process, it's above 80 here and keeps on growing and growing. At the same time, the interest comes down. So this will be done in a very short period of time. It looks like we're done in 1 year or so. But this calculation never changes, exactly the same. We put that down. That's already pre-calculated, all the interest you would have to pay, and it's spread out month by month. All we're doing is showing you in a amortization table, I have trouble pronouncing that, is if you wanted to pay it off early, you get a very good approximation as to what you'd get back or what you wouldn't have to pay. And it wouldn't make too much difference here because it's a very short-term 1-year loan, but it still makes a difference. And what they've done for convenience, for everybody's sake, is just have the same payment all the way down the line, which has various levels of interest, various levels of applying the money to the balance, and then this would eventually get down to zero, but they're not showing you all of that. But the original question was, after 5 payments, what's the equity? Well, what we have to do here is do a subtraction. This is after 5 payments. Actually, after 6 payments, I suppose. Yeah, this is another mistake. Wow. So after 6 payments, forget what they just asked, we would have paid off down to the balance of $514.92, which is pretty much the 50-50 mark. But what you've paid is a little less than that. So another mistake. This is riddled with mistakes. I should have fixed all of these. $485. Looks like that's supposed to be an 8 instead of a 0. So $485 and 8 cents. I'll just attach it to the last one. So this was an error in the amount. So it's close to the 50-50 mark. Use your calculator and subtract that out. You get $485.08, and that's what you actually own. just about half of it. Not quite half of it, though, at the halfway mark, so it's just the way the interest has gone. Okay, 4.2, continuing. Here, we're going to borrow $150,000 at an APR of 6% to buy a plot of land. And you pay off the loan in monthly payments over 10 years. Okay, let's see what this could give us. And let's see, we want to find the monthly payment, complete the 4-month amortization table, and what is your equity in the land after 4 payments. So we'll get to all that first. Let's get to the monthly payment first, because that's a very important item. And so the monthly rate, and I hope you can read this, it's a little bit small. I guess I can increase the size just a little bit, although that other junk gets in there. Go away. The monthly payment rate is 6%. That's another friendly one, no round-off error. We'll show you what we mean by one with round-off error later. That's 0.5%, 0.5%, or 0.005. So they're going to use this number here. Wake up the pen, and there it is, 0.005. Sorry, I crossed it out, but I'll also show it here in the formula as well. So we've divided by 12 for the first calculation, multiply 12 by 12 for the second calculation. That's just part of the deal. This avoids the tedious formula that assumes you haven't done any of this. So take care of getting R and T right off the top for problems like this in borrowing situations. Now this one, they actually put the correct formula down, so this is monthly payment in terms of amount borrowed. And we know we're borrowing $150,000. That's a lot of money. And the monthly rate is 0.5%, 0.005, but then 120 months. This is one of those borderline calls where it may be productive to put as many decimals as you can. However, I did notice that, well, actually, yeah, once you get past about 10 years, it's just better to go ahead and include the decimals. If you tried 6 and you weren't off by very much, this is one of those really borderline calls, but usually the longer the term, the more decimals you should include. And there are a lot of students that just include them all, and you never have anything to worry about. So this one is not quite like a 30-year mortgage, but I did try all of the decimals. So let me go ahead and put down the numbers I got to fill in some gaps here. And let's see. If you have 150,000 times 0.005, those numbers worked out to be 750. And then this 1.005 to the 120th power is 1.8193. 96734. 96734. And we have to subtract 1. It's the same thing down below, except we subtract 1. So guess what? This 1 comes off and it becomes a 0, just for emphasis. 0.8, and then ditto marks, ditto marks, ditto marks. And that was a 734, by the way, in case you haven't checked it with your own calculator. And so you divide that out, and yes, you will, to the nearest penny, get yourself $1,665.31, and that would be your monthly payment. They've already started an amortization table here, problem number 2, and let's just see if we can just go through it without checking every little detail. We have applied 0.5% of the $150,000, and this is what that number was. The 750 showed up. It's hard for me to point that out when the pen doesn't always work, but the 750 did show up here, and it does show up there. So that was applied to the interest, which is a lot of interest. That's a lot more than the other one. This isn't a mortgage, but it is a 10-year loan. I guess it is kind of a mortgage, isn't it? It's just a kind of a quicker than average. It's not a house, it's a piece of land. Well then, by subtraction from 750, the 1665 minus 750 is going to give us 915.31. That goes to the balance, so it's more than half. That's kind of good news. But look at all that interest that's kind of out the window. Well, the applied to balance comes from here. You subtract the 915 from the total, and on your calculator you find you're just a little bit above 149,000. These numbers are not quite 1,000 each time, although they are getting better. That's a hallmark of these types of payments. You apply more and more to the balance and less to the interest. So it does get slightly better, but we'll take 120 payments to finish this off. So you're not allowed to take the interest out. That's just what the bank gets. That's the money they get for doing all of this. But then you get to apply to the balance owed. And this is not like a 30-year mortgage, which sometimes starts off much worse than this, but it's still not nearly as good as the last example. And they continue, and you can see the outstanding balance and calculate equities as you want. In fact, let's take a full look at this table. And same table as before, no change. The table from This part tells us after 4 payments, we still owe this number here, the $146,311. And let's see, there it is. And they subtracted it from the total, and this is our equity after 4 months. It's kind of like the sum of these numbers. They didn't say it that way, but you could actually add these numbers up and get the equity. So the amount you're paying to the balance, and there are 4 of these $900 things, is around $3,600, and it's getting better every month, but you're still losing quite a bit of interest here. Look at the other column. But it is a price of doing business, and even though you may be shocked the first time you see it, it's either that or come up with a whole bunch more cash or something, and not everybody can come up with a whole bunch more cash. Most people cannot do that. So sometimes it's the lesser of two evils. And a lot of people get mortgages. It's just a fact of life. Not everybody does. Some people would rather not be tied down, and that's fine. Anyway, let's take a look at this next example here. This one has the home mortgage, a loan for purchase of a home. And this is the kind of the standard 30-year mortgage. There's certainly a 15-year mortgage, 20. You can get creative if you get a good lender. But anyway, we do have the APR is 9%. That's not a horrible one. 0.09 divided by 12, 0.75%. I believe we saw this one before, 0.0075. Don't really need the leading zero, but sometimes they put it in. And so when we divided by 12, we got the 0.0075, not quite a percent per month. But for 30 years, that's a whopping 360 months. And that's a big exponent here. And when you get to mortgages, the rule of thumb is use all the decimals you can. And even then, you might not be completely right. Remember, the banks get like 20 decimals in their calculations. They want to be dead on perfect with these things. And I guess occasionally you get a 40-year mortgage and stuff like that. But anyway, we're not talking about that. So as we look at this, and maybe see my little error sheet, if there's any errors on this one. This one seems to be pretty much okay. We moved past there, and we got that one done. And so now we're on number 8. Yeah, I don't see any mistakes on this one, so that's certainly good news. The amount borrowed, and we're trying to find the monthly payment, so we're trying to find what the monthly payment would be, and that's what we're looking for. And so the amount borrowed is the first thing we start off with, and that's the $300,000, check. The R there is correct. And now this major computation has to be done, and use all the decimals you can stand. And I'll put down what I got in my calculation here at the bottom of the screen. So I'm going to send it down here where there's a little more room. I'll get the first two numbers out of the way. The 300,000 times the 0.0075 is 2250. So I'll just bundle those together. That's pretty simple. And then the major number is 14. I actually made a mistake last night when I was looking these over. I got the decimal wrong. That's not 1.4, that's 14. Yeah, that's a big factor compared to before. They're getting interest on you big time. That's a factor of 14. We don't need to go into that though. 730, 576, 12. There's all those decimals. I got like 8 of them. But when we subtract 1 from the denominator, it isn't like the 1 turns into a 0. No, the 14 turns into a 13. And all the other numbers are the same. So I'll just write them all down. Some students are not bothered at all by the decimals. I'm annoyed by them, but I still do them. And yet, just do what you need to do. That's a factor of 1.0727, but I'll just go ahead and cut to the bottom line. And yes, they were correct. 2413 and 87 cents, so 2,400 or so. Well, one thing that we could do, which I'm kind of obscuring by all my extra work here, is to look at the total amount paid. So let's take a look at what that would be. When you pay 360 of these payments, look at what you're paying. Over $800,000 going on $900,000. It's a lot of money. And then look at the interest you paid. Because if we subtract away the price of the house, which is what's listed at, then this is the interest you pay. 868 minus 568 and change, minus 300, that is $568,000 in interest. That's more than half. That's about 2 to 1. Now, I'm old enough to remember in the late 70s with an 18% loan, it was more like a 4 to 1 ratio where you're getting, you're having to pay about 4 times the value of the house just to get the house. Here, it's 2.5 times, so it's still pretty bad, but that's just the way 30-year loans work. And of course, in today's historically low interest rates, it's not nearly as severe. So if you can get to getting something like that, it's right now the interest rates are quite favorable, and you would not see a terrible ratio, even over 30 years when you're down to 2.5% or so. Well, we do have different types of mortgages that we could look at. We have the fixed rate mortgage. That's the easiest one for us to calculate. We've already started to look at that, and that's fine. Adjustable rate mortgage, make sure I turn this thing on. The adjustable rate mortgage, I'm not sure how much of a need there are for those kind of things right now with such low interest rates. They can't really head any further down. So who would want an adjustable rate? It's only going to go up. So I don't think they're very popular right now, but they have been very popular in the past. So what they want to do is compare the two. And so we're going to borrow $200,000 for a 30-year home mortgage. And apparently the APR is 6.6% for a fixed rate mortgage, but only 6% for an ARM, that is adjustable rate mortgage. Let me underline the word. So let's compare the initial monthly payments. Of course, that doesn't really answer the question so well, but at least we can take a look at it. And I believe I've already corrected a couple of the mistakes I found as I got in a little bit earlier here. So in both cases, the principal is $200,000, and in each case, 360-month, 30-year payment, and they've already calculated that out for you. 6.6% is what this was, so I'll remind you, 6.6%, and that does work out to be 0.066 divided by 12. That is not rounded. That is just exactly 0.0055. Okay, so the amount borrowed here, $200,000. And then the R comes in, 0.0055. But then we have to take 1 plus the R, 1.0055. They had the wrong number in there. To the 360th power. That's a big number. You don't want to make a mistake with that. Use the same number again. You don't have to recalculate it. All you have to do is subtract 1, though, and you'll get something decent. So don't have a lot of room to cram this stuff in, but let me see if I can do that a little bit. From this first example here, the first two numbers are 1100. That's the simple part. And then we would have to get in the numbers, and the 1.0055 to the 360th power, that's only a 7. The other was a 14. So this number isn't quite as awful. 355, 66, 48. We do have to subtract 1. 7 minus 1 is 6. So if you put it that way, it doesn't look so horrible, does it? But copying all the decimals down is maybe the challenging part. And if you don't, you could be off by quite a lot. And it's surprising how fast it occurs. And it just depends on the case. Sometimes you can get lucky and use 7 decimal places and hit it to the nearest penny, just the way it goes. Or sometimes you're off by a couple $100, and that's not acceptable. We would not be able to give you credit for that, not very much anyway. Some probably, but anyway, we'll talk about that as we get closer to the test. And okay, let's take a look at what happens when we change it to 6%. This is only part of the story, which I'll clarify later, but the amount borrowed, they slipped in the wrong number. They called it 300,000. I'm going to make sure that's a 200,000, but the rest of the numbers are fine. So let me see if I can squeeze this into the bottom of the page and wake up the pen again. And so 200,000 times 0.005, the first two numbers on this formula on the second example, that's exactly $1,000. So that's certainly a nice round number. But then 1.005, only 5%, because we divided the 6% by 12 and got 0.5%, 0.005, that's 0.5% per month. We have 360 months, that's what gets targeted. And so now the number's down to a 6. These numbers are getting better all the time, all things considered. And you can imagine what it would be like for 3% or something like that. So it's getting more reasonable. Even if it is for 30 years, low interest rates will really go a long ways to keeping your money your money. So anyway, I put in those numbers, and that's really hard to read. That's 212. It's more for your example to see that you put down all the decimals your calculator can give you. But if you have one that gives you like 14 decimal places, I'd probably only go for 9 or 10. And though we subtracted 1, 6 minus 1 is 5. So 5.022575212. And when you divide that all out, I pre-checked this, and yes, you're down to $1,199.10. That's about $78 less. So you'd say, oh, let's do that. Of course, this is an adjustable rate mortgage. And just because it's this way this year maybe even for a couple of years. But what about when it jumps up somewhat? Well, then they're going to recalculate everything. And actually, getting an amortization table at that point would be really not pleasant and really not practical, because nobody knows which way an adjustable rate will go, except we're going up and down like a roller coaster. And in high interest times, it may be a good gamble to take, but this isn't them. And I don't know anybody who would be taking one. And if there's any exception to this, I'm just not into real estate, so there may be some exceptions I'm missing about all that stuff. Let's just get into the first couple slides or so of 4.3. This is about saving. And some of this we saw already, so this is kind of in a different perspective. If we deposit $100 to our savings account at the end of each month, and maybe the account pays a monthly rate of 1% on the balance in the account, well, that's 12% per year, and they're, of course, dividing by 12. And this time they're just giving it to you in terms of monthly. So that's a bit unusual. They almost never do this, but they did this time. And so monthly, I'll get this pen to work, a monthly rate of 1%. It's also APR of 12, but let's not worry about that. Find the balance at the end of 3 months. So this one they just go through one at a time. You could form a little table here. At the end of the first month, simply you deposit $100. There's no interest been given to you yet. But at the second month, that interest kicks in. You get 1% of 100, which is pretty darn easy. That's $1. $1 plus 100, yeah. And plus the other 100, don't forget the previous balance. You have up to $201. Well, the previous balance, as we do the calculation for the third month, the previous balance was 201. And then we take 1% of that number. We're up to $2.01 of interest. This looks familiar. And let's not forget the deposits. Now we're up to $303.01. So let's go and take a look at this little table. It's just a regular deposit table. I don't think this would be called an amortization table, because you're not borrowing. You're just seeing what your deposits will be worth soon. And so here we had the $100 deposit, and we had the $201 from the next one, and then the $2.01 that we talked about at the end gives us a deposits or balance so far of $303.01. Notice all the deposits are the same. Apparently this experiment ends after 10 months. So each one gets a little bit more interest, because we look at the previous balance, $303.01. We take 1% of that and just round it to the nearest penny. Yeah, I know there could be some overages of tenths of a cent and all that might round in a certain direction. We're just not going to worry about that. We'll let the bankers get into that kind of detail. We're not going to do that. So $3.03 is added. Now we're up to $406.04, and on and on and on. And at the end there, we're getting $9.37 worth of interest, and we get to add that plus the 100, and so we're getting some money. Now notice if there had been no interest at all, 10 times 100 would be 1,000. So I'll just go ahead and say that 10 times 100 would be 1,000. So it's a simple matter here to see that we've earned $46.22 in interest overall, and that kind of gets into the APY kind of thing. But this is not actually a full year yet, so that's actually not quite accurate, but after 10 months at least, that's how it would go. So just one more example here. Let's take a look at this final example. Regular deposits balance, and so we could use a formula instead of having to generate it one little step at a time, which is a little on the tedious side. Although if you find it fun to see how much money is coming your way, go for it. But most people might consider a formula or Excel spreadsheet or something. Okay, so the balance after T deposits, and these are just about always monthly deposits, but just in case they decided not to do that. So let's see, we would have to use that. And so we put in the deposit, and we take 1 plus R to the T, subtract 1, and just divide by R. So this is a slightly easier formula. And in this particular case, they pulled a kind of a weird percent out of there, so there's a little bit of round off on that one we'll talk about. But we earn 7% annual percentage rate. We deposit $20 to the account at the end of each month for 5 years. What's the account balance after 5 years? Let's see what this final slide has to tell us. So the monthly interest rate, R, is equal to 0.07 times 12. They did not want to tell you that. That's kind of unfortunate. And so let's go ahead and realize this is only for 5 years. We could probably get by with less decimals. And actually, I could show you a little bit of a problem with that. but I'll get to that in a second. 0.005833. I'll put down 6 decimals and be done with it. And then the number of deposits is 5 times 12, or 60 deposits over 5 years every month. So the regular deposit formula, which is correct, is given to all this stuff here. And we'll put in the $20 deposit every month. And then we put in, and I'll go ahead and give you my work on this one, 20 times 1.0058. Actually, when I calculated this, I put all the decimals in my calculator. You may not want to do this, but I'll go ahead and put down them all, so that way we have 3 extra 3s, a little bit more tedious there. And that has to be raised to the 60th power. And 60 is not a small number. It's not 360, but it's not the other one number either. So I'm going to have to actually put extra parentheses in, I suppose, and there's a 20 sitting on the outside. Sorry about the scribbles. And cross that out. Okay, then we just divide by 0.0058, and then as many 3s as you can stand. I guess I'll do that. And when we get a little bit more information, the 1.00583333, 0.07 over 12, which they don't want to tell you much about, and then you subtract the 1. I'll go ahead and just do that in one step. I actually got 1.417 something, so I'm going to say 20 times 0.417, and then 62526. And that's divided by 0.005833. This is kind of the boring stuff. This is why we do Excel. But yet, for us to test you on this, I'm afraid this is all we have for you right now. So it's kind of a necessary evil. Excel will be a little bit more fun, certainly more instantaneous. Well, when you crank that all out, you'll get the expected number, the 1430,186. But it does bear some mention that if you only use 5 decimal places, the value you get is 1432.65, I believe. It's hard for me to read my own handwriting. Oh, 69 cents. Okay, so that's for 5 digits, 5 decimals. So 6 is generally better. This is one of those borderline calls, and it's yet to be determined what I would do for something like this. I don't think you'd lose very much. I'd be tempted to take off 1 point because it is off by just about $1, but I just have to see how the rest of the class goes. So this would be kind of like majority rules. So then I'd have to suggest 6 decimal places. When you get to 6, you're just either dead on or off by just a few cents, and that's not nearly as bad. But yeah, I was just prepared for the worst. As I put down the example, I put down all the decimals, which I guess is 9 decimals. Yeah, so that's a lot. And some people have no trouble writing a bunch of decimals down. And if that's you, then it's probably safest to write them all down. But if you'd rather try to round it, don't even think about rounding it to anything less than 5 decimals. That's just going to be ridiculous in most cases. 6 is a little bit better. 9, well, might be a little excessive here, but we're not at a mortgage. Mortgage is like, 360 months. This is only 60 months, so the level of severity isn't quite so bad, but it's already starting to measure up a little bit, and a banker would go crazy over something like this, almost $1 off. Oh my goodness! And even mathematicians don't like that, but I'm willing to accept a little bit of round off error, and hopefully there won't be a lot of that. And with Excel, there would never be any of that, so we'll be getting to that pretty soon. So either coming up very soon or shortly after Chapter 4, we'll start to show you some of the stuff with Excel. We are, I guess, a little bit ahead of pace. I think I'd rather be a little bit ahead than a little bit behind. So Excel will have time to look for the videos, see if there's any new videos, and go through the stages on that, and try to do some of those live as well. So it might work out a little bit better live. Well, I guess that's about it for today. We'll continue with 4.3 next time as we go out live next Thursday. I don't have the day of the week, what that is right now, but it'll be coming up next Thursday for 4.3. Don't think we'll have a chance to get to 4.4 on that one. So anyway, have a nice holiday weekend. Well, or I hope you had a nice holiday weekend, and you could see this as early maybe as Saturday. But talk to you soon, and we'll see you live. And WebAssign should be up and running by then. That was the other thing I was going to mention. They gave it to me so late, and there's some password issues and linking to my old account. And so the nightmare goes on. Luckily, we don't have to worry about it until the 29th, I believe. So we'll try to get you ready for WebAssign as soon as possible. All right. See you later. Bye-bye.